Alright, so this video is on section 7.6. I'm going to try and do this in as few words as possible since it's a little difficult for me to talk with you guys. So you can print these notes off from the email that I sent out or from the group that I started for our class. So these first couple ones are kind of just little good fill in the blank, good to know kind of thing. They're not too important for how you're actually going to solve the problems. The first part says integration by tables is the procedure of integrating by means of using an appendix of integrals. So it's not so much for the benefit of having you memorize them or having you learn the integrals, but more so just being able to use the table of integrals as a resource and being able to use the appendices, as a resource for when you solve integrable problems that are more difficult and ones that you may or may not have to necessarily commit to memory for the AP test. It says integration by tables requires considerable thought and insight and often involves substitution. So it's trying to figure out, how to match the problem that you're given to the tables and what's actually listed in the table and trying to find the best pick or the best match for which one you're using. You can use a computer algebra system to figure it out. So essentially you could use a computer to figure it out for you. The main difference is that with a computer algebra system, the computer searches through its database to find a fit. Whereas with the integration tables like the appendices or the back of the book, you have to find out whichever one fits the best. So for example, in our book it's actually Appendix D, not Appendix B. So using this one, we're going to be looking and trying to figure out, exactly how we know which one matches it and why we know that. So here's what I'm looking at, and I'll kind of talk you guys through my thought process so that you can kind of see where I'm coming from. So first of all, I see an X here and I see an X here, and you should know that whenever you're looking in the tables, they're always going to use the letter U to represent the variable. So wherever you see a U, that's where you're looking for variables. So I'm guessing that I'm going to make my U the variable. I notice that I have another constant right here on the bottom with it, so I'm looking for something that looks like maybe the integral of u over some constant a minus u. So I'm looking for whichever table of integrals, whichever integral fits this one the best. So I found number 3. If you guys look in Appendix D in the back of the book, the third one looks something like that. It has a plus instead of a minus, but that's fine. And the only other thing is that it has a b. But that makes sense. I guess you could say that the constant in front of u is -1. So it says list the substitutions you would use. So I'm saying that u equals x, a equals 3, because that's what we have here. A is 3. And then b is -1. And actually, if we put in one more in there, I would say that du equals 1 dx, just so that you can see that substitution as well for dx. And then recognizing that if we actually did want to solve the integral, that would be the answer, just plugging in what b and a and everything equals. And then for example 2 down here, if we look here, again, still Appendix D, not B, I see some constant 3, which I can pull out, so that one doesn't really matter, so I'm actually going to ignore the 3. I see a u, because again there's an x, so I'm seeing u to some power. I'm going to put n, because usually they represent powers with n, and they represent the u's, or the x's as u's. So it's u to some power, x to the 5th, that's u to some power, ln of u du. So then I'm going to flip to the back of the book. I'm going to see if I can find one that looks kind of like that, and I actually found one that looks exactly like that. Number 89. So I know again that u would be x, I know that the power is 5, so n would be 5, and again du would be 1 dx. Now that 3 that's out front, I'm just going to say that's a constant, so I'm going to pull it out front. It doesn't really affect the integral since it's a constant, so I'm not going to really worry about what I would substitute for that. Alright, we're going to do 3 examples today. It's going to be a short little video, so go ahead and copy them down as we go through them. Alright, so here's example 1. It's in your book under 7.6. I'm not sure of the page off the top of my head, but just look under section 7.6. So again, as I'm looking here, I see u's for x's. So if I'm trying to find the format of this, here's what it looks kind of like to me. I'm going to pull the dx out because I don't like it there. So I see 1 over I'm going to say that's a u square root of u minus a, or plus or minus a, so I'm just going to put plus or minus a, dx, or du actually in this case. So I'm going to look for one that looks kind of like that. Why don't you pause the video and flip to the back and try and find one of them that you think would work, and then unpause it, and we'll go talk about which one it is together. So I found out that the one that fits the best is actually number 17. So it's actually the integral of 1 over u square root of a plus bu du equals 2 over, and I know it's the bottom half, because if you look at the very end it says when a is less than 1, and in our case if we switch them, a is actually less than 1, it's a negative 1. So it's 2 over negative a arctangent of the square root of a plus bu over negative a plus c. So in this case, u is x. A, if we flip these here, it would be negative 1 plus x. So that means that a is negative 1. B is 1. And du is 1 dx. And again, I'm just getting the du from taking the derivative right there, by the way. And the rest of it I'm just matching up. So I know that u is x because I see a u here, a u here, u here, x here kind of thing. A is negative 1 because that's the first piece under the square root. And then b is just the coefficient of x, which is 1. So when I plug all these things in my answer, so I'm going to plug them all in here, I get 2 over the square root of negative a. So 2 over the square root of negative 1 would be the square root of 1, which is just 1. Tangent inverse of the square root of a, so negative 1 plus b, which is 1, times u, which is x, over negative a, so negative 1 again is 1. So when I write this as my final answer, I get 2 tangent inverse of the square root of, I'm going to flip those back to like they were originally, so x minus 1 plus c. And that's the final answer for that piece. Alright, let's try another one. Alright, let's try and match this one up. So let's see, x, that's a u square root of, I'm not really sure about this one. I guess I could do u to the 4th minus a du. Try to look for that in the back. And you may or may not notice that you actually won't find something like that in the back. So then I'm going to start looking for other options. So if you notice, this piece is a perfect square, and this piece, well, if we look up here, this piece and this piece are both perfect squares. So I'm going to alter this a little bit. I'm going to say, okay, inside of here at least, it's if I make u equal to x squared, then this would be u squared minus 3 squared, or a squared I should say, if we make a equal to 3. And there is something like that in the back of the book, but then what do we do with this x? And the key to that, if you look at the back of the book to try and find this one, it's actually number 26. It says that the integral of the square root of u squared minus a squared, or actually plus or minus a squared, but in our case it's minus, du equals 1/2 times u, the square root of u squared minus a squared ln of u plus the square root of u squared minus a squared. And then at the very end, it's just plus c. Sorry, that's kind of squished in there, but essentially look at number 26. That should help you figure out the rest of what I kind of scrunched in there. So we already said that u was x squared, a is 3. If we take du, that's where that extra x comes from, because du is 2x dx. So I have my x dx here, so I gotta get rid of that 2, so I'm just going to divide both sides by 2. So this is 1/2 du equals x dx. So I have that extra 1/2. So if I rewrite it, it looks like this. It looks like the integral, I'm going to pull that extra 1/2 out. The integral of the square root of u squared minus a squared du. Because of this 1/2, it came out from right here. So when I plug those into the function for what it equals, I'm going to get the 1/2 that I already have here. And now I'm going to start reading here and plugging in the things that I know. So I have another 1/2, so that's times 1/2. U, which is x squared, square root of u squared, so x to the 4th minus a squared, which is 9. Minus a squared, which is 9, ln of the absolute value of u, which is x squared, plus the square root of u squared, so x to the 4th minus 9, plus c. And actually, in my original one, there should be parentheses around this too, so there's parentheses like that. So the 1/2 can get multiplied, that's 1/4 times x squared square root of x to the 4th minus 9 ln of the absolute value of x squared plus the absolute value of x to the 4th minus 9 plus c. And that's the final answer for that one. And then last but not least, we have the integral of x over 1 plus e to the negative x squared dx. Now the key piece of information here I should say, is that we have this e to the negative x squared, and that's another exponent in there that we have that has an x in it. So when I'm looking at this, I see I see that maybe u is going to equal negative x squared, because most of the time I just see e to the u. So if that's true, then that means du would be negative 2x dx. And if I try to get rid of that negative 2, I get that negative 1/2 du equals x dx. So I can rewrite this as the integral of negative 1/2 of 1 over 1 plus e to the u du. And if you look in the back of the book, there's an integral that fits this one. It's actually number 84. So it says that this simplifies to the negative 1/2 that's out front times u, which is negative x squared, minus ln of 1 plus e to the negative x squared, e to the u, plus c. So if you just distribute that negative, since everything's already negative inside, you can make it more positive. You just get 1/2 x squared plus ln of 1 plus e to the negative x squared plus c. So like I said, short video. We're not going to cover a lot today. We'll finish the rest tomorrow. I just wanted to get you guys started on this section. Again, this section of the book isn't especially helpful for memorizing them, but it is especially helpful for figuring out integrals when you need to do them fast.